This is 2.5. This is going to be on implicit differentiation. So basically what we're talking about in this section is that everything we've done up until this point has been in a perfect way y equals. Y by itself equals without anything else with the y. What we need to understand is that when we are taking derivatives, we are actually writing our functions with respect to x. Y is a function of x. Y is a function of x. So when we take the derivative, we're taking the derivative with respect to x. So the question becomes is, what happens when we start writing things implicitly where we have x and y on the same side of the equation, when y is not isolated, when we have exponents on y, things like that. And the issue is that when you are taking the derivative with respect to another variable, for example, in this case, x, any other variable that shows up still needs to take the derivative, but we are taking the derivative using the chain rule. So for example, if I say we have y equals 1, it doesn't really matter. If I want the derivative of y with respect to x, we know the derivative of 1 is 0. But when we take the derivative of y, technically what we're doing is we are saying the derivative of y is 1 times y prime, just like we do with the chain rule. When we, if we were to say we have a quantity squared, we take 2 times the quantity and then take the derivative of the quantity. That's the same thing here. We would take that 1, multiply it by the quantity and keep it the same, and then multiply it by the derivative. That's why we end up with y prime. So how does that work? Well, exactly the way we just said. For this one, example is, take the derivative. It's going to be y prime equals 3. And you can also write that as dy dx equals 3. The derivative with respect to x. So that means anytime that we're taking the derivative of anything other than x, the chain rule will have to be applied. So what we're assuming is we're assuming that our y is equal to something. So if our y is equal to something, then we have to apply the chain rule here. So what does that mean? We take the derivative as normal. The derivative of y squared will be 2y. But that is only the outer portion, so to speak, of this. We still need to take the derivative of y itself, which is just y prime. And then we do the other side the exact same way. So we have 2y times y prime equals 3. Now, the one key to this is making sure that you should always be solving for y prime in the end, because we want to know what y prime is. So we would divide by 2y on both sides here. And we end up with y prime equals 3 over 2y. So it really isn't that hard of a process. It's really you getting used to the fact that whenever you take the derivative of something other than, in this case, x, because that's what we're trying to get the derivative with respect to, we have to apply the chain rule, meaning we do the derivative as we normally see it, but then have to make sure we multiply by the derivative at the end. So now let's get to a little bit more complicated one here. We have x squared times y squared equals 6. We do have a product here. So I'm going to identify my x as my f and my y as my g. So then I identify my f prime as being 2x. My g prime, because it's a y and we're taking the derivative with respect to x, this will be 2y times y prime. Now we apply our product rule. F prime times g, so we have 2x times y squared plus, and then our other one we have g prime, which is 2y and y prime times x squared. And then the biggest mistake that is made on this, it's not equal to 6. What's the derivative of 6? 0. Okay, that's the number one mistake. Most people leave that as 6. Now we have to solve for y prime. So how do we do that? Well, we first have to get wherever y prime is, or the number of y primes, we need to isolate it by itself. So I will leave that where it's at. So 2y, y prime, x squared equals, and I'm going to subtract this to both sides. So then we end up with negative 2x y squared. And then really all we have left to do is divide everything off of this except for the y prime. So therefore we have y prime equals, this will stay on top, negative 2x y squared divided by 2x squared and then y. So I just divided everything except for y prime over to the other side. Now we want to simplify this. So we end up with the negative 2 divided by 2 is negative 1. So we have negative on top. We have a y left over on top. And we have an x left over on bottom. Okay? So what I want you to do is I want you to do this one up here on your own. Try it. All I want you to do on your own for right now, unless you know how to do it, is I only need you to do the first part, which is just taking the derivative. Do not worry about isolating y prime. We'll do that when you come back. But I do want to see if you can do this one on your own, just taking the derivative, that first step, and then, and seeing where we're at after the first step. So go ahead and try that on your own, and we'll see what you come up with. Okay, so your first step here is just going through and doing the derivative of each one. So the derivative of y to the third is 3y squared times y prime, plus derivative of y squared is 2y times y prime. The derivative of negative 5y is negative 5 times y prime. And then the x squared is done normally, so minus 2x, and then equals derivative of negative 4 is 0. So that's your first step. The last step is isolating your y prime. This is actually pretty easy to do. But again, what you want to do is whenever you're trying to isolate a y prime, get all of your y primes on the same side of the equal sign, and anything that doesn't have a y prime will go on the other side. So we're keeping all the y primes on the left, and then we're going to bring the 2x over to the other side by adding it. Now, since every one of our terms has a y prime, we can factor out a y prime. So we have y prime on the outside, and you're left with 3y squared plus 2y minus 5 equals 2x. And then again, just to get y prime by itself, we just divide out whatever's left. So we have y prime equals 2x on top and 3y squared plus 2y minus 5 on the bottom. And that is our derivative. So that may seem a little bit complicated, but hopefully we're getting the hang of it. We're going to work on this more in class, so I will see you then.